Welcome back, everybody. Turn your monitor sideways if you would for, I don't know, however long I ramble on. Let's talk about some stuff. Try to teach you something useful. Just wait until your monitors get sideways. Cool. So we are in week 10, which you can see on the Blackboard deal, which means that in your assignments, you need to be through all this week 9 and then do your week 10 stuff. Some people are, the visual mood controller program. You should be able to do this right here at Fresno City College. I think the software is already installed, but get Visual Studio Express. And so there's Visual Studio Express. Downloads, Visual Studio. New edition available. That's kind of wild looking. Visual Studio Express editions for desktop, for Windows. That'd probably be fine right there for Windows. Creation of desktop apps for Windows. I'd go with this one right here. But then you'll do a little program using Visual Basic. I wouldn't be teaching you Visual Basic if it's up to me. But it's not. Like, there's certain things I just have to teach you because it's like the community college law. You have to teach this in this course. So I made the coolest assignment I could out of that. But I could help you in here if you need help with it. So it'll be cool. So that's what you need to do for your assignments there. And then since we're in week 10 here, this is week 1. This is week 2, 3, 4, 5. This is week 6, 7, 8, 9. And so now we're going into the first one of access, right? And there's 4 in there, plus you need to do your exams, so you need to be through exam 10. And you should probably also, inside exams, there's Office lab tests, and there's one for Excel, so you should do the Excel one, since we're done with Excel. All right, so that's kind of the layout of the week. You got those things, normal routine, that's what you need to get done. And, yeah. So today we'll talk a little bit about multimedia. I don't know, kind of a weird topic to me. Multimedia is just, but it's often a topic that's included when talking about this stuff. And we do deal with a lot of media. So I'm just looking in your book's index here at what chapters we've covered so far in the textbook. And we did chapter 1, technology to change the world. 2, looking at computers, understanding the parts. Chapter 3 was the internet and the World Wide Web. 4 was application software. 5 was system software. There is a focus on ethics. We'll talk about that like week 15 or something, or 16. And then chapter 6 was understanding hardware, evaluating your system. Chapter 7 was networking. Chapter 8 was digital devices and media. Chapter 9 was securing your system, protecting yourself. Chapter 10, software programming. So, you can see like what we talk about, what I talk about doesn't necessarily correspond to the book. Chapter 11 is databases and information systems. 12 is networking and security in the business world. And 13 is how the internet works. It looks like a pretty interesting book. I should probably read it. Had I but whirled enough in time. So just I guess some of the main things to point out about multimedia is mini media, and so it's just bringing media together. And first of all, if you think about how have humans sort of conveyed information, back in the day we were storytellers, right? We'd sit around the fire and we'd talk story, and that's it. That's all we had. No cable, man. No cable. No like iPhones. Nothing. And then after that, we had writing, so we paint on cave walls, paint pictures, and then we got letters, right? And so that'd be like single media, right? Like letters on a page, single media. That's monomedia. I'm just making that up. It's not an official term. And then, letters and pictures, and put it into a book, right? Cool, we got pictures, we got letters. Maybe we could say that's multimedia. There's pictures, there's letters. But you might still just call that single media. It's print. And then there's like newspapers, black and white. That's it. And then there's radio. Ooh, now we're getting sound. And then there's TV. There's sound. There's images. There's text. Now we're starting to draw some stuff together, right? So multimedia is just like all the media bringing it together. And it's pretty amazing, you know, what you could do with computers today. You know, so I know this is like an old movie, The Matrix, but like, you know, just the special effects, you know, that you're able to achieve with movies. So, you know, there's this YouTube video, and it's called, oh, don't start playing something, because I'm not supposed to record anything. That's other people's material. YouTube flags you if you put up like other people's music and stuff. You guys know that. All right, so let's say, what is it I'm looking for? Kid, what's the kid? That's not the one I'm looking for. It's funny what comes up. Kid, it's not Star Wars Kid. Let me find it, hang on. So it's an action movie kid, and anyhow, if you're watching this video online of me right now, you could go to YouTube and watch action movie kid, and then come back. There we go. So pretty cool, you know, what you could do these days with technology and computers, and so like, you know, being able to edit put in special effects. There's a piece of software. Adobe makes a lot of image editing, art software, and Adobe After Effects, right, was how all those special effects are created. But like, those are really amazing special effects. Like, go back and watch Titanic from the late 90s, and it's like, you know, there's a couple scenes where like that's digitized and you're like, that looks so corny, right? And it's like, you could do stuff better than that on your own home computer now using a piece of software which costs you a couple $100, right? Like back when I went to college, I was like, maybe it'd be cool to make movies. And, you know, if you wanted to make movies, you had to shoot it on film. And then you like process the film, and you'd like cut the film and like tape the film together. That's how you made your edits. Right? Now if you want to make a movie, we had that movie making assignment. You could use Windows Movie Maker for, you know, just a goofy home movie. Or you could use Final Cut Pro, right, which is the Apple product, or Adobe Premiere, right? And those are like heavy-hitting, hardcore, beautiful, amazing, create outstanding movie video editing software. Right? Like, you could get a camera and make movies, whatever, movies or music videos or anything, you know, and it'll cost you less than $5,000 to get like a really good system, right? So that's pretty amazing. And even when you go to YouTube, right, like you just upload your stupid phone video to YouTube, you could go into your channel. And then once you're inside your channel, you could go into Video Manager. And once you're inside Video Manager, you could click on Create. And you could add audio, different soundtracks to your, you know, so in here you could add music to your YouTube videos. And this is all licensed and everything, so you don't have to worry about messing up. It looks like you might be able to download it even, so then you could edit it right in. I didn't realize you could do that. And so that's, you know, you can get sound effects. Cordless drill, high pitch, and just download those. So that's great, right? Video, audio library. Then they have a video editor here, so you can drag your videos here, drag your audio here, and you know, you can start to do different stuff. I've never even used this, but like right here, you've got a little video editor just right on the web. Like, how sweet is that? You know, it's almost worth to start trying to play with it a little bit, but. So when you guys make your video assignment, right, I said, hey, Windows Movie Maker, just shoot it on your phone, upload it to YouTube, and you know, drag the video there and drag some audio there. And I imagine here's where we'd find audio to drag over there, right? And I'm not sure, get some photos, you know, or oh, you could remix, you could get video clips, right? Creative Commons video clips. Here are your transitions. You could drop in some text. So kind of cool that all that stuff's available. So how do computers store images? So let's just start with an image. How do computers store images?
Raster or vector?
Aha! I think, Dave, you should just get up here and talk, man. I think you're going to be like, Todd, you don't know what you're talking about with images. So that's a great question. Dave said, I always thought it was raster. Is it raster?
No, it probably is raster. I was
raster. Raster.
Is it
I'm going to get a
wash or
raster.
Depends on what part
There we
of the
go.
picture you're in.
Raster define. Raster. Raster. A rectangular pattern of parallel scanning lines followed by the electron beam on a television screen or computer monitor. Raster. That's not quite the definition I was looking for. See if there's that. A raster graphics image is a dot matrix data structure representing a generally rectangular grid of pixels or points of color viewable via a monitor, paper, or other display medium. Raster images are stored in image files in varying formats. Yuck, yuck, yuck. And then we have vector images, right? And define. So vector graphics is the use of geometrical primitives such as points, lines, curves, and shapes or polygons, all of which are based on mathematical expressions to represent images in computer graphics. Vector graphics are based on vectors, makes sense, which lead through locations called control points or nodes. So a raster image is also sometimes known as a bit-mapped image, bitmap. How many people have heard bitmap? Yeah, so it's just mapping bits.
Do they not use bitmap anymore?
I don't know.
Because I used to prefer that over JPEG, and everyone was just like, "I'm just going to do a JPEG," and I was just like,
Well, JPEG is also, I think, categorized as bitmap.
Well, yeah,
mapping
used to
bits.
Be, like save as bitmap.
Yeah, yeah. There's a BMP.
Yeah.
There used to be a BMP. It probably still is. We could check.
Yeah.
So if you wanted, I don't know what I just opened. I opened pho. If you wanted to edit a photo, file open, and documents, I don't know. There we go. There's a picture of me. And if I zoom in on this image, eventually you're going to see each little pixel. So an image is made up of pixels, right? And that's like a really close-up of my throat. But, right, that's all it is pixels. And each pixel is a color. You can see there's a wide variety of colors there. And so that's called mapping bits. That's also a raster, right? So raster is probably the more correct term, but you call it bitmap. And there's different file formats for raster images. So GIF, PNG, JPEG, right, are all some of the ones we've heard of. If you're a professional photographer, you might use RAW. So just different file formats, right? What's the difference between those file formats? Oh, man, go for it.
Compression?
Compression. What's that mean?
The file's compressed and shrink. All the pixels are put in one form. In the raw form, it can be changed, but the compression can't change it back after it's compressed.
Yeah. So everything comes down to storing zeros and ones. That's all computers know. Okay? Zeros and ones. That's all we could store. So each one of these pixels, we have to store that color. And we talked about bit depth and color depth the very first week or the second week. So bit depth or color depth, if we look that up, just see what comes up. In audio, bit depth is the number of bits of information in each sample. And then there's color depth, bit depth or color depth, right? So here's color depth. And color depth is how many pixels or how many bits for each pixel. So if we have 1 bit for each pixel, we get to store black and white. That's it, 1 bit, right? Because each pixel can store, it could either be 0 or 1. That's what we're storing for each pixel. And so 0 or 1, then it can be black or white. We can associate, if it's 0, it's black. If it's 1, it's white. Right? So 2 colors with 1 bit. Bit depth, color depth. Color depth is probably the more correct term. Color depth of 2 bits is 4 colors. Okay, so a little bit more, right? Because if we have 2 bits, we can store 4 pieces of information. 0, 0, 1, 1, 0, 1, 1, 0, right? So any of those 4 patterns for each pixel, we're storing one of 4 colors. 4 bits, we could store 16 colors. Whoa, just 4 bits, right? And we're starting to get a little bit of color in there. But still not all that great. And you know what's trippy about this? Let's say, so what's the resolution? What's the resolution on that photo I opened right here?
800 by 800?
Do you see that somewhere?
No, I'm just guessing.
Oh.
Oh, it's like 5 by...
So image and image size, and it's 100%, but let's go to pixels. 557 by 557, width and height. Okay, 557 by 557 is 908.9 kilobytes. So 557 by 557. So if I had a picture that was 10 by 10, 10 width, 10 height, how many pixels do I have total? My image is 10 by 10, right? 10 width, 10 height. How many pixels total? I'm asking for area. It's 100, right? Because I got 10, if it's 10 high, then I have 10 rows, right? 10 highs, 10 rows, and each row's got 10. So if I got 10 rows with each row having 10, that's 100, right? So if I have 100 pixels, and each pixel has a bit depth of 4, I'm storing 400 bits. Okay, and if I divide that by 8, if I divide that by 8, I am storing 50 bytes. And if I divide that by 8 times 1024, right, I'm storing 0.04 kilobytes. Okay, we'll come back to that little formula right there in a second. But if my pixel is if my picture is 557 times 557, that's 310,249 pixels. And if my bit depth, my color depth is 4, that's 1,240,996 bits I got to store with a color depth of 4, right? And if I divide that by put some extra parens there. That's 151 kilobytes. We saw that this was 908 kilobytes. So let's go back here. There's a color depth of 4. Here's a color depth of 8. So we have 256 colors for each pixel. Here's a color depth of 24. So we have 16,777,216 possible colors for each pixel. That's a wide palette to paint from. And so that picture looks pretty good, right? So if my image of 557 by 557 is 24, not 4, the color depth is 24 instead of 4, I have 908 kilobytes. I did not think that was going to come out that way. 908.9 kilobytes. 908.9 kilobytes. Whoa! I'm like just totally surprised myself.
Where are you getting the 8 divided by 1024? What's that?
So that's just here I have how many bits, and so if I divide by 8, I get bytes, and if I do bytes times 1024, I get kilobytes. There's 1024 kilobytes. There's 1024 bytes in each kilobyte, so that gives me kilobytes. You just figured out, like, give me the dimensions of your image, right? And I could tell you how many zeros and ones are being stored there. And that's kind of cool. So the key terms that you just learned are color depth, right? That's one of them. And then also pixels. So we've already heard that phrase quite a bit. I feel like we should be looking at some other part of my body. Let's do right on the eye. See what my eye looks up like close up. I don't know if that's creepy or not. Eyebrow, hair. It's kind of weird that it's made up of just these squares of color. But you get enough of them and you get far enough away and it, like right there, it like goes boop, right? So when you get really close, that's pixelated, right? You could also sometimes hear that it called rasterized because we're seeing the pixels.
I used to like refer to it being like JPEG because that's why I preferred the bitmap over the JPEG because the JPEG used to be like that. Rasterized is what I would consider taking like a vector and converting it.
Yeah, that's probably more accurate. Listen to what he said.
Well, no, what you said makes sense too, though.
Pixelated is what people call that, so we'll stick with pixelated. Definitely. So you learn pixels, you learn color depth, you learned, okay, you know, based upon my color depth, I could represent more colors and get truer colors. And you learn raster versus vector. So let's look at a vector image. And so for vector images, you would use Illustrator, Adobe Illustrator. So Photoshop lets me work with raster images, right? Illustrator, and you can see like, oh, that looks totally different. Illustrator lets me work with vector images, like lines and things like that. I don't know if I have any vectors on my computer. I don't work with Illustrator that much. This was a vector. Which one was it? I don't remember the name of it. That one. That's a vector. Right? Just kind of a drawing. Not a lot of shades and color. Just yellow and black. But kind of cool. Have I showed you guys this? I showed you this, right?
I don't think so. Well, I missed it.
Yeah, I wrote a bunch of books. One point in my life, I was like wanting to be a writer. Really liked writing when I was younger.
Why don't you write your own book for the class and then make more money on that way? I had a teacher do that.
Yeah, that'd be a good idea. There's only so much time.
And that way you won't have to say, maybe I should read the book. You'll be like, hey, I wrote the book.
Some of these, I haven't read a lot of these books. I wrote them, I haven't read them.
It's a lot, man.
Yeah, I haven't published them all. Kind of fun. So that's let's see if that opened up. See what we got. What is kerning? See definition. Grapefruit. It's a space between letters. Where did it go, man? Oh, I'm in there. File, open recent files. Logo red. Logo AI. Logo green. Create down. Font awesome. That's awesome. Beautiful logo. Peace.
And the checkerboard's not part of the graphic. That's just the
No,
background.
yeah, the checkerboard's just the background. But that's a vector. All right, so it's defined by line. So I could scale this 50 gazillion times. I'm never going to pixelate because the vector, the math, just keeps getting redrawn. Right? So this could go up the side of a skyscraper. It'll be crisp and clear. Because they just redraw it, right? Pixels, you never see the pixels. That's a vector. I don't think I want to show you anything else in Photoshop. I think I did show you at the beginning of the semester all the images. I did, right? Like how you could change things so easily these days. You guys know that, right? It's been Photoshopped. Everything's Photoshopped. Like, there is no reality in images, except maybe news images and images from friends. But like media, advertising, that's all high gloss. The model doesn't even look like the model, right? It's true. They're like, let's make her hips, her waist a little thinner, her hips a little wider. You know, just adjust it all. And it's like, wow, I don't even look anything like that, the model's probably saying. So you'll sometimes hear coding schemes or codecs, compression, decompression. So when you talk about JPEG, PNG, GIF, RAW, so we take a photo, we get information. Every little point is a color, that's a pixel. How much of that are we going to store? Right? The more information we store, the more flexibility we have. Right? So if I take a really large photo, I could zoom in, zoom in, zoom in, and it won't pixelate. But I had to store a lot of information. I stored a lot of pixels, right, for a really high resolution image. Resolution is your width and your height. So if I shoot super high resolution, I've got flexibility. I could take a picture of the classroom, and I could just crop in on Arlen and put up a picture of Arlen, and it'll look good. Because I shot super high resolution, so I was able to zoom in without things getting pixelated. Right? But that's storing a lot of data. And then also my color depth, how much am I storing each pixel? And so sometimes we give up file size. There's an inverse relationship between file size and quality. So we could decrease the file size. No, direct relationship. Decrease the file size, and we decrease quality. Increase the file size, we increase quality. Right? And sometimes when you throw away data to decrease the file size, you'll never be able to get that data back. And that's called loss-E, lossy compression. I lost it. That data's gone. It's lossy. And sometimes you could throw away data, and you could run an algorithm to get rid of the data, but then you could run that algorithm in reverse kind of and get that data back. And that's called lossless. You never lose the information when you compress. So you just learned a couple new terms. Codec, compression, decompression is what codec stands for. You spell that codec. A device or program that compresses data to enable faster transmission and decompresses received data. Compression, decompression. Okay, so codec. And there's lossy compression. And then there's also lossless compression. So mostly who cares, right? Keep your original. You know, compress it, use it somewhere, and if you ever need to go back, you got your original. Maybe it'd matter if you're running some sort of a website and people are uploading photos and you're like, I don't want to store everything, but you know, so I gotta compress it. Now, do I want to compress it and be able to come back to the original for that user? In which case, I need to use lossless, some sort of lossless compression, or do I just want to be lossy and throw it away, right? And you can never get back to your original. So Google Photos. Well, you're gonna see my life. Haha. Curious? I'm curious. What's up there? I'm recording. I don't know. I don't think I have anything. I'm checking it out. DevFest photos from this weekend. Here's my Traeger barbecue is like not working, so I took a picture. It's like wood chip barbecue. It's kind of cool. But Google Photos uses lossy, right? You upload your photos and they throw data away. You can't get it back. I'm pretty sure. Unless in the background they have lossless because they want the data. So you learned codec, lossy, lossless. So compression, decompression algorithm can either be lossy or lossless. Lossy, lossless, right? And so the difference, you know, JPEG, difference between JPEG, PNG, GIF, RAW, is like how much data do they throw away, and in what way, right? So let me ask you this. Let's say we took a photo of the German flag. You can get me banned from YouTube, man. I don't know, that ringtone's like common Creative Commons. whatever. We took this photo. How would we create a compression algorithm, some sort of computer program, to store this data? How would we create like our own algorithm to store this data instead of storing the color of each pixel, which you can see there's going to be a lot of redundancy there, right? Instead of storing the color of each pixel, what kind of a mathematical formula can we write in a computer program to compress this down to a smaller file size? How would you go about doing it? What do you just start thinking from like logic perspective?
All the yellow gets grouped together, or all the red gets grouped together.
That's it, man. Right? From this point here to this point is all this yellow color. From this point here to this point is all red.
So rather than storing each cell, you would say range from this
Yeah,
cell
yeah,
to the end
yeah,
of this cell.
yeah,
Yeah.
yeah. It's all black. And now we just have to like have some program that could read, okay, go from this point to this point and fill it in with black. Then go from this point to that point, filled in with this color red. Go from this point to this point, filled in with this color yellow. And then, for people to use our codec, they would need to have whatever, because we'll compress it that way for them. Then they need to know how to decompress it, right? So they get that little chunk of code that says, hey, from this point to this point, yellow, this point to this point, black, this point to this point, red. That's just some code. They need to be able, their computer needs to be able to read that and say, okay, now I'll write it out and fill it in. And that'd be the decompression. And so that's why you get things like JPEG, PNG, GIF, right? They have certain ways to like represent and abstract and sort of say, hey, there's some color over this area or whatever, right? They compress it in some ways. And our computers know how to read JPEGs. Our computers know how to read PNGs. Our computers know how to decompress it and how to read GIFs. And so that's the compression decompression. How many people have learned something at least somewhat interesting? It's cool. All right, good. What are some of your favorite flags in the world? We're going to go on. This is officially a tangent. What's one of your favorite flags in the world?
Cambodia.
Cambodia? That one's going to be a little harder to compress, but that's cool. That's Siem Reap right there. Angkor Wat. Angkor Wat. It's in Siem Reap is Cambodia's old name, right?
Siem Reap?
Siem Reap. Isn't it Cambodia's former name? No, what's Siem Reap?
It's
Thailand.
It's a city in Cambodia.
Oh, it's a city in Cambodia. Okay, I don't know what that is. Are you Cambodian?
Yeah.
Cool. Congratulations, man, for making it here. Cambodia is a hard place. Like, pretty impoverished. 1 in 5 kids under the age of 5 die.
I was born here, but that definitely my parents. Because they did immigrate here during that whole crisis.
Yeah. Yeah, dude, the entire Pol Pot deal.
The 70s.
They got out. That's good. Yeah, I was there in 2010. Yeah, Angkor Wat. Just kind of traveled around there. It was pretty cool. Cambodia has the largest amount of landmines left in a country, just randomly, and lots of people just out walking their ox. It's bad. Yeah, left over from. And then they had like a lot of tomb raiders because they have a lot of cool stuff, and so they have guards at like Angkor Wat who are authorized to shoot on site anybody who's not supposed to be there after hours. You're in the wrong place, man.
Things like we have a really bad illegal logging problem, so we have a lot of people who, like guards, who will protect forests, things like that. And they see you chopping down a tree.
Yeah. Yeah, different parts of the world, there's a little less thought that goes into the judicial decision of guilty or innocent.
Yeah.
You're in the wrong place at the wrong time.
Either that or you just walk around the forest and you get blown up by a landmine.
All right, what other flag? Favorite flags? We're lucky. I'm telling you, you guys already won the lottery.
Burma.
Burma? I like that one. That's cool. I like this one. Barbados.
Traded.
Yeah, very Neptune-y. There's always a yeah, Bob Marley. See that one quite a bit around college campuses. All right, so that's compression, decompression, and images, and so these different encoding file formats, right? Encoding schemes. Compression, decompression, bitmap, mapping bits, right? We saw that. Some of them can be animated, right? PNGs and GIFs can be animated. Some of them can have transparency, so you can see these dice have some transparency, right? And then we looked at vector images and we talked about compression. Audio also, right? So how do we take music and turn it into zeros and ones? Whoa. Right? Like, think about that, man. How do we take music and turn it into zeros and ones? You put a CD into your car player, that's zeros and ones. How's it come out?
Yeah, exactly.
I'm going to get flagged on YouTube. It sounded just like it, didn't it?
I recognized it. I got a bad ear.
I could do some more singing for you, or you guys could start talking. What do you want? How do you compress? How do you capture audio and turn it into zeros and ones?
You record it?
How do you think about doing it? How did we do it with modems? Modulate, demodulate, right? And a low pitch is going to be like 0, and a high pitch will be 1, or whatever the heck they do with it, right? Is it the opposite? So we could take a sample. So if we have bits per sample, and this is bit depth, right? We saw bit depth when I was looking for color depth, and bit depth is audio. So color depth, pictures, bit depth, audio, right? So if we take a sample at one slice in time, one nanosecond, right? A nanosecond is one billionth of a second. I don't know if we're going to take that many slices.
Jesus.
What other seconds do we have? Nano, micro? Is that one? I don't know. What are the categories for seconds? Who knows? I got to look that up. But if we take a slice in time of a sound, can we find that exact note? That exact pitch?
Yep.
Yeah, right? So it's this note or this pitch. And if we have a bit depth of 1 for each sample we take, then we could either store high or low. One of those two, right? It's either high or low. If we have a bit depth of 2, we can store 4 sounds. If we have a bit depth of 3, we can store 8 sounds. Just like with colors, the greater our bit depth, right, the more possible sounds we could store. So if we have 24 bits per sample, we have a bit depth of 24 for each sound, we could store 16,777,216 different pitches. Have you ever heard of 44.1 kilohertz? Does that sound familiar? Sound quality. So here, 44.1 kilohertz, CD audio. So having a little bit of fear I never hit record again. Look at that. Sample rates are used. Higher sample rates are used. 44.1 kilohertz and 48 kilohertz DVD. Kilohertz is thousands of samples per second. 44,100 samples a second. What? You're sampling the pitch 44,100 times every second? And then for each of those samples, you have some sort of a bit depth. Let's say it's 24. We just stored 1,058,400 bits for each second? So let's say we have a 3-minute song. We just stored
You only did 3 seconds.
3 minute. Yeah, I was like, that's not the right size. We stored 190,512,000 zeros and ones for a 3-minute song at 44.1 kilohertz and 24, a bit depth of 24 bits per sample. Took me a second to find the right way to say that.
That's only like a meg though.
Okay, so let's check it out. How big is that?
Oh wait. No, that's like
We got that much. And we divide it by 8. Now we have bytes. And then we divide it by 8 times 1024, and we have megabytes. Kilobytes, sorry. And then we add this to it. I think that's what you do for megabytes, not 1,000. It's 22 megabytes. 22 megabytes, that's not that big.
It's still pretty big for a song though, usually like 3 to 5.
MP3 is 3 to 5.
Okay.
I don't know what the bit depth is for audio, CD audio bit depth. 2 can be perfectly described by more than 2B samples per second. What's the bit depth?
And the MP3 obviously be the more compressed.
So it's 16 bits per sample and 2 channels, right? So 16 bits per sample, but it's stereo, so you got left and right. So this is a CD quality 3-minute song. It's 30 megabytes. And then MP3 would be a tenth of that, or a sixth to a tenth of it.
Sounds about right. We've got like 20 songs on an album around the CD. That's quite a few, so we got plenty.
Yeah, so if you have on an album, $363
Yeah, so like half.
megabytes, because a CD will hold like 600 to 750 CD capacity. 700 megabytes, right? So we could store, how many songs on a CD? How many 3-minute songs? I didn't do that right. I need this here. 23 songs. 3-minute songs on a CD. You want 5-minute songs? I'd have to change this to what? 300. 13. And I got 300 here, 5 minutes times 60 seconds. Or 3 minutes times 60 seconds was 180. So we have sample rate, which is the number of samples a second. Resolution, or I'm going to just change that right now. Bit depth. Sample rate times bit depth times number of channels. So 44,100 per second. And bit depth was 16. And number of channels was 2. And that's for 1 second. The amount of data stored for 1 second. That's kind of crazy, man. That's crazy. That's so crazy, brah. Like, it's like so many things happening to, like, I can't even conceive. Zeros and ones. just flown through the system. Like, who could look up that much stuff in like 44,100 times a second? It's looking up 32 zeros and ones. What? Like, for me to look up 32 zeros and ones 44,100 times, that's going to take me a couple weeks. Right? I'm going to be at that a long time. Computer can do it in a second. Whoa.
No, less than a second.
Yeah, less than a second.
3 more zeros and ones stereo versus mono.
2. Twice as much data. Yeah, 2 channels.
And the 2 channels is not very much there. It's usually like 4 or 6.
Yeah, there's like Dolby 5 or whatever.
Yeah.
Crazy. Crazy cool. So that's audio. You can kind of listen to, like, you know, differences in quality. You can listen to, like, it gets bigger.
Nice.
I'm just completely screwing up this. There we go. I can't move it. Help me. Help me. There we go. Cool. So MP3, WMA, makes me think of Ultimate Fighting for some reason.
You got 64 in there. Oh, I see. It's MP3
There we go.
versus WMA. Was it Windows Media? What's the A stand for? Audio. Oh, okay.
MP3, MIDI, wave. I don't know, this doesn't tell me much. It's an old slide. Alright, so that's pictures, that's audio. It all comes back to like capturing zeros and ones, taking samples, whether it's pixels or one slice in time. And then movies, right? Editing movies, editing photos. Last thing that I might show, which is interesting, if you're watching this online, you could stop if you want. But just like, how do you start working with images programmatically? I've been banging my head against this wall recently. It's the first time I've kind of tried to do it. It's kind of interesting. So if I have an image here, which is that one, 787, 1293, and so that's 787, 1293 right there. And if I sort of go reveal in Finder, it's right here, and I could see that that image is, why doesn't it show me the dimensions of it?
Get into the properties.
Yeah, it needs to be in a photo folder, which is why it's kind of nuts. Let me see if I open it, if it shows me.
It's all Macintosh anyway.
Get info. So here is more info. 3867 by 2577 is its dimensions, its resolution. And so here I have a program which is going to open that file, opens it, and assigns it to a variable reader, right? And then I'm going to use JPEG decode because it's JPEG. So I'm going to decode that file, and that'll give me another variable m. I assign that to m, and once I have m, I could do things like, you know, find out the bounds of it. And so I run that little function m bounds and assign it to bounds, and then I could say, hey, bounds dx, bounds dy, right? And I could figure out the resolution. So when I run this, how many people find this interesting? How many people do not? If you don't raise your hand, I'm just going to keep going. How many people find this interesting? How many people do not?
I'm a little confused.
What confused you?
I just kind of got lost in it there for a second.
Oh, you just open a file, you assign it to a variable, and then you decode that file. So it's just like there's a function that you could just run. It comes from the standard library of this programming language, and it decodes it, and you assign that to a variable. So decode, if you look at that, it says decode reads a JPEG image and returns it as an image, and so you could look, okay, what's an image? And if you go and you look at what an image is, godoc.org is image JPEG. So here we go. So image is a type, is basically has color model bounds, and you could do something there. So I get that, and then I could run bounds. So anyhow, when I run this program, this is interesting. I don't guarantee it, but all right, so Code Clinic, 02, and then 0201. So when I run this program, it looked at that image, and it said, okay, here's your resolution. Here are your total pixels. Cool. So let's see what else we could do with this. I'm going to open up the second step in here, and here, right? Open it. I decode it. So I get the M. I say bounds. I can get my dimensions and stuff again, but then I'm just going to print that out. Like what comes out when I print out a decoded image? Okay. Just out of curiosity. Opens it. Now it's looking at it. Trip out.
Huh. I was going to say they're all less than 256, right? But the last one's 3,872. Is the number like representing the color in between 0 and 256?
I'm not totally sure. I think this is a slice of bytes. And here's the slice notation, and then after it, we have a little bit more information. Right?
3872, that was the width of it, wasn't it?
Subsample ratio.
Yeah. And then there's something YCBCR. And I remember over here in the documentation, there's in the image package, there's something YCBCR. So it's a type. So something about type, and then I have different functions I could work with maybe here. Huh?
It says subsample ratio.
Subsample ratio, that's right. There we go. I never studied images or computer science, so this is all a bit of mystery to me. But I'm just playing around with it. Anyhow, I got all this stuff out. I'm not totally sure what those things are. Right? Like, but they look like, it's some data of some sort. So let's play with it some more, see what happens. This is just like my thought process. I just start playing with stuff. I'm like curious. So here, same thing, open it, decode it, width, height, and then I say I want to see the type. So I say print the type of that out. And when I do that, it gives me image YCBCR. Okay, cool. So I was kind of thinking it might be JPEG, but maybe somehow JPEG's connected to YCBCR. Not quite sure what YCBCR is, something to learn about. And then I come in here, and now I have this other thing, right? So now I could do a loop. And I'm going to go y is equal to the minimum on the y. And when it gets to the maximum on the y, stop. So basically this loop right here, which goes from here to there, that loop is saying start at my first row, and for images, that's the top left corner, right? So that's 0, 0. It's kind of weird with images. 0, 0 is the top left corner, and I have like 74% certainty about this, so I might be completely off. It might be totally different with YCBCR or something. But And then for each row, we're going to look at each row. So we're looping through each row. So this is the way a loop works in programming. You start like right here. Like if I want to do a basic loop, you guys want to see a basic loop? If I want to do a basic loop, this is how you do it. So for I equals 0, while I is less than or equal to 100, right? So this will say this is your init, your initializer, this is your condition, and this is your post. And so this starts out at 0, I starts out at 0, and this condition tests it. Is 0 less than 100? Yes. Okay, I'm going to run this code then inside the loop. I'm going to print 0. And then I'll add, this is my post, so after I'm done doing whatever's in the loop, I add 1 to I. That's what the plus plus means. Right? Add 1 to I. So I is now 1. Is 1 less than 100? Yes. So print 1. And 1 plus 1 is 2. I is now 2. Is 2 less than 100? Yes. Print 2. Right? Add 1 to 2. It's now 3. Is 3 less than 100? So on and so forth. 99. 99 less than or equal to 100? Yeah. Print 99. Add 1. It's 100. Is 100 less than or equal to 100? Yeah. Print 100. It's now 101. Is 101 less than or equal to? No. Out. Not going to do it anymore. So that's the init, the condition, the post. So same thing right here. Just like I'm getting my numbers a little bit more of a complicated way. So my init start out at the minimum y coordinate, right? The minimum y coordinate, 0, if that's what it is for the image. And I'm going to go until the maximum y coordinate, my last row, right? And each time I'm just going to add 1 to y. So I go through each of my rows. When I go through each of my rows, I'm now going to go through each of my pixels in each row. So for each row, start at the min for x, because what is x? It's the column. So I'm in that row. Now go to that first position in the column, which is that first pixel. And keep going until we get to the very last pixel. So let's look at each pixel. And for each pixel, I could do m at xy, give me the RGBA info. Red, green, blue, alpha, which is one way we can store stuff. I do know RGBA. I do not know the YC, BC, whatever that other thing was.
Cyan, magenta, yellow, and black. The K stands for black because the blue and the black both have B's, so they take the K from black.
Ooh, do not know that.
Yeah.
I think I might need to go back and play with that, though.
Mm-hmm.
So then I print that. I print out my RGBA. Let's see what we get. This is number 4. So that is the color information of every pixel. RGBA. So each line is 1 pixel. RGBA. And there's like 3,700 times 3,700. We're going to be watching a couple million of this. What is 3,700 times? So what were my dimensions? 3867, 2577. 3867 times, well heck, I think my dimensions are right here. I didn't list them. 3867 times 2577. So we're going to see 9,965,259 items printed, and it's already done. It printed the information for 9 million pixels. Oh my gosh. I got to see that again, but this time I think I want to drop in right here. And I'm going to drop in right here I, and I'm going to do I is equal to 0, and then I'm going to do I++. I'm going to print whatever pixel we're looking at. It is that fast. We're already at 2 million, 3 million, 4 million, 5 million, 6 million, 7 million, 8 million, 9 million, 9,965,258. 9,965,259. What? Why the difference? I started at 0. I didn't start at 1. Right? This right here is if you start at 1. Here I started at 0, so I'm 1 shorter. Whoa.
Wow.
Bill Gates saw this when he started getting involved in computers. He thought, imagine if those were dollars going into my bank account. And you know what? He has so much more than that. That's only 9 million. You know how many millions are in a billion? 1,000. 1,000 millions. You know how many billions he's worth? Bill Gates' net worth. 79.2 billion. Donald Trump's 4 billion. Warren Buffett's 66. Zuckerberg's 35.
It's funny that Zuckerberg's ahead of Trump.
Losers.
Who's the second?
Huh?
Who's second in the world?
Is he first in the world?
I believe he's first in the world now. I remember there was one year he was second. Okay, Carlos.
Bill Gates. Carlos Santana.
Slim.
Who knew?
That's my style. Who's that Carlos guy?
Carlos Slim is I believe he's head of Five. No, not Five. It's,
Source of wealth telecommunications.
yeah. He owns basically all of the telecommunications in Mexico.
Ooh. Mexico or South America?
Mexico.
Yeah.
So that's cool. So my the challenge that I had here was so you got this image, and then you have this image. Right, there's that image. There's this image, and this image comes from that image. Can I somehow find, like, look at all the data in here, and then look at the data here, and tell that this data is a subset of that data? Right? Well, if I know, if I give you guys, did I tell you this already? No? Yes? I told one of my classes. Didn't tell it to you? So let me give you a challenge. I'm going to give you, here it is. You have to see it. Right? So there's my big picture. And that's my little picture. Is QRST inside of the big one?
Sure.
Yeah, that's from the big one, right? So I can say, cool, QRST is part came out of that big one because it matches. Same thing, I just have to look at all the zeros and ones and tell the computer, like, is this bunch of zeros and ones come from that bunch of zeros and ones? Oh, it's in there, cool. But the data gets so large, I haven't figured out quite how to do it yet in a timely fashion. So that's what I'm kind of stuck on. Right, you could tell, like, this is not from that other string, right? Oh, that doesn't belong from that other one.
Seems like it wouldn't be like a nice fit either because it's going through the whole row.
Right.
We need to isolate the columns.
I have to check one row and then go to the next one at the same starting point and see if that matches, that matches, that matches. Okay, we got a match. Right. So I'll just take that very first row right here. Does that match anywhere? And if so, then go to the next one down. And is the next one down here match the next one down there? Cool, cool, cool,
Certainly
cool.
would it match for a while? It'd be pretty close to, well, a quarter of the way through it before it matched.
But Google has algorithms to do that with music and with videos. So you upload a video, and it's like, this has already been uploaded. They know. Or you upload a video, and it's like, man, you're sampling James Brown. You don't have permission for that. Like, you know, they have things that check every video. It's like, whoa. So there's this great video. Maybe end with that because it's totally worth looking at. But YouTube. Wow, I have 163 because I have all these references. Copyright. And then 4. I think this is it.
Oh, it's ridiculous. It's like a
Right,
$1 million
YouTube.
or something.
Statistics. Statics. Statistics, YouTube. Over 1 billion users. Well, they don't even say anymore. They used to say how many videos were being uploaded and yeah, I don't see that anymore. They say how many videos are being uploaded, how much content every minute, but like they have so much stuff coming up. I wish that was still up there because that was great stuff. Anyhow, watch that video if you're online. I'm going to stop the online class now.